Hello, this is Professor Brown Cedarberg, and we're going to look at the Java number food chain. This is the number Java food chain. That is the primitive types that we can use to store numbers within the Java programming language. You'll see that each type has a name, a number of bytes required in storage to store something of that type, and the kind of number that can be stored there, whether it be an integer or floating point. Bytes are at the lowest end of the food chain, doubles at the high end. So our first element in the Java number food chain is the simple byte. It requires 1 byte of storage. It can hold an integer, a whole number. It can hold an integer within the range of -128 to +127. Next in our food chain is the short. The short requires 2 bytes, also holds an integer, and will hold numbers in the range -32,768 to +32,767. Next in our food chain, the int. The int requires 4 bytes, also holds an integer, will hold a number in this range: 2,147,483,648 negative to +2,147,483,647. Next in our food chain, the long. The long requires 8 bytes, also holds an integer, will hold a number in this range. That's 9,223,372,000,000,000,000, 36,854,775,808 negative to positive 9,223,375,875,807. A wide range of whole numbers. You'll note that all of our primitive types so far in the food chain all hold integer values. Our next element is a float. And a float requires 4 bytes. It will hold floating point numbers, numbers with decimal values. The range for a floating point number is this: positive or negative 3.40282,347 times 10 raised to the +38th. That means I can move that decimal point 38 positions to the right. The other end of my range is positive and negative 1.40239846 times 10 raised to the -45th. That means I'll move that decimal position 45 positions to the left. A wide range of numbers. Next on my food chain, the double. The double requires 8 bytes, will hold floating point numbers. It will hold floating point numbers in this range: positive and negative 1.7976931348623157 times 10 raised to the 308th, which means the positive 308th, which means I can move that decimal position 308 positions to the right. The other end of the range is positive and negative 4.940656458412 times 10 raised to the -324th, which means I can move that decimal position 324 positions to the left, an even wider range of numbers than we find in the float. Now this is the completed number food chain for Java, all the primitive types that will hold numbers. We have on the low end the byte, the high end the double. Now, our food chain allows us to have something of a type lower on the food chain stored into a space declared to be of a type higher in the food chain. So a byte can be stored into a short can be stored into an int can be stored into a long can be stored into a float, and a float can be stored into a double. Anything lower on the food chain can be stored into a space declared to be of a type higher on the food chain. So a byte can be stored into a short and into an int and a long and a float and a double. A short can be stored into an int, a long, a float, or a double. An int into a long, a float, or double. A long into a float or a double. A float into a double. Something lower on the food chain can be stored into a space declared to be of a type higher on the food chain, but not vice versa. A double cannot be stored into a float, nor into a long and into short or a byte. A float cannot be stored into a long and into short or byte, etc. Only something lower on the food chain can be stored into a space declared to be of a type higher on the food chain. So that's our completed Java number food chain. Thank you.